After completing the experiment, we then want to analyze the data. So first, let's start with the results section of this. In the results, we want to collect data in an organized form during the investigation. So think of a data table. And then we also want to present our data in an easy to read way, such as a graph. As we look at the analysis section of our results, we can only make statements about what the data is telling us. So we're not drawing any conclusions yet, just simply showing and talking about what the data says. We can highlight any trends or patterns seen in the data, and we also want to discuss any potential errors in the data. So let's talk about why we would want to talk about the errors in our data. Usually we try to hide these things, but in science it's really important that you share your errors, because if you recall, we said that we want our our experiments to be objective, which means that they need to be the same for everyone. And if I don't share things that went wrong, then we won't have an objective experiment. After analyzing our data, we can finally draw conclusions and communicate about them. So here we want to make an explicit statement about whether your hypothesis was supported or rejected by your experimental data. We use key words here and say that your data may support your prediction, or we can say that your data may fail to support or reject your prediction. But notice, data does not prove or disprove. Those are words we do not use. So just a little side note of why we don't use these two words of prove or disprove is because science is just the best answer that we have right now. In the future, they may come along with something that shows that we're wrong currently. So we're not proving or disproving, just the best answer for right now. It's also important that we describe any real-world applications or uses for the information learned from the investigation. Now let's move on to talking about overall uses of science and technology. So science itself is the advancement of knowledge. And so what we're trying to do is answer questions based on our observations, whereas technology is the advancement of society, which means that we're solving problems based on our particular needs. So technology is the application of scientific discoveries to meet human needs and goals through the development of products and processes, whereas engineering applies scientific and mathematic principles to solve problems. So now let's talk about technological design and why it is that we're using math and science to improve society. So first, let's talk about problem identification. We need to clearly define the problem or the need. Then we have solution design. So we want to brainstorm, research, sketch, and narrow down to best design for product or process, all within the constraints such as cost effectiveness, time effectiveness, materials, whether that's availability, durability, environmentally conscious, and etc. And we need to remember that a perfect design is never possible, but the benefits of our design need to outweigh the risks of the design. When implementing our technology, we want to build and test and continually make improvements in our designs. And we also want to evaluate them. So determine if you have solved the problem and met all of the constraints of the project.